My name is Alec Mendes, and today we're going to study a quick little session on conics. First things first, what is a conic? Well, a conic, as it sounds, is very much like a cone. So let's draw a cone. That's about right. It's like a cone. But this cone is actually like this, more of an hourglass shape. Okay. In a graph, a conic won't occur like in traditional graphs, because as you know, here we have the y axis, so we have the x axis. In order to have the 3D aspect of the conic, we need another axis, which is called the z-axis. So an easy way to visualize this is you have a square, and with this, I'm not a great artist, but you kind of get the idea. This, you have kind of a 3D square. Of course, like we can erase. Well, doesn't matter, you get the point. Well, so conic So a conic can also have different cuts. A cut is something, this is just a rough conic. A cut is what you expect it to be. A cut, that's a cut. Imagine a knife slashing, like Fruit Ninja. It's a cut, that's a cut, this is a cut, that's a cut. What we're going to see is each type of cut. There are 4 shapes that can be created with a conic. First is the circle, then is the ellipsis, the ellipse, I'm sorry. Then we have the parabola, and then the hyperbola. Very simple, right? Circle, ellipse, parabola, and a hyperbola. Very nice. So we're going to go on a step-by-step analysis of each of these shapes. Let's start with a shape that we all know and love, a circle. To see how we get a circle as a cut for a conic, we're going to use a very good tool that's going to help us determine what's going on. Sorry about that. Okay, here we have a cone. Also, quick note, these two, we're going to call them bases. A real conic does not have a base. It stretches infinitely. But for the sake of simplicity, this is a base. We can toy around with the height. And it changes this. As you can see, it's 3D. Height changes. Slant also affects, and as you can see, the graph is also being affected. M, or the slope, also. Here we're moving the cut. The graph is moving as well. And B, or the Y intercept. Okay, so let's start what we were looking for. Let's try to get a circle. In order to find the circle better, let's watch it with a bird's eye view. Here we can see there's a parabola, or like a parabolic shape. Let's start moving M just to see what happens. Here we can also see what's going on. And it's almost a circle, and well, we now have a circle. Let's change the slant. No effect. It is still a circle, but the radius is changing. The height, absolutely no change. Of course, in the cut, well, in the circle, the shape, the cut is being shifted. But what does this tell us? Well, this tells us that when when M equals 0, then the shape that will appear will be a circle. That's nice. Let's see what happens if we have a circle and we start changing B. Starts getting smaller and smaller. The cut is getting shorter. And now we're right on the vertex of the cones. We start, and it starts growing again. So this tells us that as the circle or the cut gets closer to the axis, the shorter the cut will be, and the circle's radius decreases. That's interesting. Also, another interesting aspect, regardless of the height or the y-intercept, the circle will always be, the cut will always be parallel to the base. Remember, base is like a bit tricky because there's no base, but it stays parallel. Okay, that was a good overview. Also, how do we sketch a circle in a conic? Well, let's try to do this. Then, I'm sorry, I'm not an artist. Oh, no, but that was bad even for me. Let's see. This looks good enough. Okay, so let's do blue. And let's pick another circle. So a bird's eye view would be kind of like this. So we have a circle, and then here we have like the cut. It's parallel, perfect, and it's a circle. It's good. Okay then. Now let's move to our next shape. We're gonna move to our ellipse. It's like an oval shape, but we're going to call it an ellipse. Now we're going to have to find the properties that give us the ellipse. So let's toy around with this again. Let's reset parameters. Let's start with m. So m is decreasing. Zoom out a bit. Look at this. We have a parabola. Start decreasing, decreasing. We got 0, which we already know is a circle. And again, it's becoming into a parabola. Let's see how the slant affects this. Let's see what happens when we get to 1. And the slant is 1. Well, when they're equal, we can see that the ellipse is broken. Less than 1 and the ellipse is back. Greater than 1 and there's no ellipse to be found. So, what does this mean? If the slant is now, let's say 2, and we have 1.9, we still have a ellipse. But now if this is a 2, the ellipse is gone. If this is a negative 2, this is gone, a negative 1.9, and the ellipse is there. So, what does this tell us? Well, it tells us that the absolute value of m has to be less than s, or the slant. So if I were to have a negative 3m and a slant of 4, theoretically we should have an ellipse. Let's test it out. So an m of negative 3 and a slant of 4. We do have a ellipse. And let's see the cut. So we can see there's a cut like this. And let's observe what happens once we start getting closer to the axis. Do you see what happens here? So, like the circle, once the ellipse or the cut starts getting closer to the axis or the origin of the conic, it starts getting, in the graph view, it starts getting smaller and smaller and smaller. But on the cone view, it's the other way around. It starts off fairly small. It starts growing and growing, and then turns to a little dot. Then it's big again, starts getting little and little. Right? Let's see. It's growing, it's growing, it's growing. But on the graph it's getting smaller. And then the other thing happens. Because the cut is going away from the origin. So, yes. Now we're gonna take a look at our hyperbola. So let's go to our little tool over here, reset parameters, and let's start increasing our m, or our slope. Let's see what's going on. Well, there's nothing I can see. Or maybe I'm not zoomed out enough. Oh, look at this. We have a hyperbola. Now let's increase the slant to 2. The hyperbola is gone. But following our pattern, let's say 2.2. And is there a hyperbola? There is. So what does this tell us? Well, it tells us the absolute value of m is greater than the slant. So if we have a 3 and here we have a 2 for slant, we should have a hyperbola. 2, 3. Look at that. There's a hyperbola. Very nice. Now we're gonna draw our conic, and well, let's see what happens with a hyperbola. As the hyperbola starts to get closer, as it starts to get closer to the origin, once b equals 0, we get this, which lines perfectly with one of the lines here, which tells us the slope of the cone. Unlike the others, we're gonna have 2 lines here. We could have something kind of like, well, like this, just like that. There's 2 marks. So that's interesting. Now let's finally check on our parabola. So a parabola is like shaped like this. Parabola. Let's go to our trusty tool. Let's reset parameters and let's get going. Oh, just like that, we have a parabola. Let's increase m. We have a hyperbola. Let's make it 0. We got a circle. Let's do 0.5. We got an ellipse. What does that mean? Let's make our slant into, I don't know, 4. And our m, let's make it into 4 as well. Oh, we got a parabola. This is a parameter as well. So what does this tell us? Let's try, I just want to try one. Still a parabola. Perfect. Well, this tells us that the absolute value of m equals s for a parabola. So, like we just tested out, 4 equals 4, which makes 4 equal 4. That's very nice. Now let's see what happens when we make our parabola get closer towards the center. Starts increasing. And just like the hyperbola, we eventually get the slope of a line. Yeah, like that. Now, this happens for the same reason as the hyperbola. The difference is that a hyperbola, when you look at it, has like an X shape, and a parabola has one. Because when you see it in a graph view, the hyperbola is like two parabolas back to back. And when they get close to each other, very close, it's like this. If there is only a parabola, then they will only get half of the x, which is very interesting. And those are the basics for creating the shapes and the cuts and everything about a conic. So let's have a small review. Circle is absolute value of m equal to 0. Ellipse is absolute value of m is less than your slant. For a hyperbola is when our absolute, well, I don't know why I put negative. I'm sorry, I think I put negative on all of them. Just absolute value of m is greater than slant. And finally, for a parabola, so value of m is equal to s. And now you know the basics of a conic.